All right, hi everyone and welcome back. Today I want to look at how you go about writing electron configurations using the SPD notation. And the only way I recommend you do it is to look at your periodic table. So the first thing you want to do is find the element on the periodic table. Find the element on the periodic table, and then you're going to count across using the s, p, and d orbitals until you've figured out and accounted for all of the electrons. Now this sounds complicated. It's not that bad. So let me show you. Okay, so let's say we are interested in finding the electron configuration of silicon here. I'm not going to use that tool. I am going to circle it. So we want to find silicon. Silicon is here, number 14 on the periodic table. Because it's number 14 on the periodic table, that means it has 14 electrons. So our electron configuration must identify 14 electrons. So we're going to start off. We're looking for silicon. And if we look along in the top part here, you can see that there's your 1s orbital. So we're going to have level 1, we're going to have an s orbital, it's going to have 2 electrons in there. You can see that silicon there is sitting in that 3p block. That's where we're aiming for. So we've got to fill everything up to that point first. So we've got our 1s orbital, we'll go down to the next row, we've got our 2s orbital. The 2 should be, the second 2s should be superscripted, but I'm not going to try and do that on this program. Okay, then we have our 2p orbital, and we can fit 6 electrons in that. We have our 3s orbital, and we can fit 2 electrons in that. And finally we come over to the 3p orbital, which is where silicon sits. And silicon, you can see, is the second element in that row, which means that it's only going to have 2 electrons in that orbital. And if we add up all of these electrons, so 1 is 2, we've got 2 electrons. 2 is 2, that's another 2, so that makes 4. 2p is 6, so another 6, so that makes 10. 2 is 12, and 2 more is 14. That is the correct number of electrons. Okay, now let's think about something slightly more challenging. Let's think about iron. Now, iron is number 26 on the periodic table. It is here. We're going to do the same thing though. So we're going to start off with our iron. Now you'll see that iron is in the 3d orbital. Because iron is in the 3d orbital, that means we need to fill all the orbitals before 3d. So we're going to start with our 1s, always 1s. Then we're going to go to our 2s, takes 2 electrons. 2p has 6. 3s has 2 electrons. 3p takes another 6 electrons. So that's the first 3 rows of the periodic table, the first 18 electrons. Now is the point where it becomes slightly tricky, because we're going to have our 4s orbital first. You can see that's on the left-hand side before we get to the 3d orbitals. Okay, that's our potassium and calcium. And then we're going to have our 3d orbitals, and as you can see, iron is 3d6. Done. Just that easy. It's not so bad. Okay. Finally, I'd like to show you one more example on this. And this final example I'd like to show you is bromine. Bromine sits out here. You need to be able to do electron configurations up to krypton, which is the next one past bromine. So this is as far as you need to go. But hopefully you can see, now that you start to see the pattern, actually you could keep going and going. It's going to follow exactly the same pattern. So bromine, again, we're going to see how bromine's sitting there in the 4p orbital. That means we've got to fill up everything before the 4p has to be completely filled. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p5. Because if you count along from there, you'll see that there bromine is the 5th atom along in that 4p block. Now, of course, when you sit in your exam, you get given a periodic table. It doesn't have your 1s, 2s, 3s, 4p, 3d, whatever on there. So you do have to know where these sit. But once you know that, then filling these out becomes very straightforward. Now, there are 2 exceptions that you need to be aware of when it comes to filling electron orbitals, and they are chromium and copper. Now, chromium and copper, because of the way they work, can become slightly more stable if you shift around a couple of electrons. Basically, it comes down to the idea that half-filled electrons are more stable than just generally partially filled electrons. So if we were to start with chromium, and where it sits in the periodic table, it's element number 24, then what we should have is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. But actually what we get, rather than the 4s2, 3d4, we get 4s1, 3d5. So one electron is promoted from that 4s orbital into the 3d orbital, which then means that both the 4s and the 3d are exactly half full. That makes it more stable. Copper does the same thing, but instead of being 4s2, 3d9, it becomes 4s1, 3d10. So those are some slight exceptions. Now, just for a bit of fun, I would like to show you a video that might just help you remember how to do some of these. Okay, I'm not sure if this is going to record properly, but if not, do check this out. Mark Rosengarten's I Heart Electron Config. Okay, so the sound recording there wasn't working, but please do check out that video. This tune is ridiculously catchy. It gets stuck in your head. You're going to hate it, and it will help you remember it. I'm not going to sing it here, but please do check out Mark Rosengarten's songs. They are fantastic. They're great for learning some of the key concepts of chemistry. Okay, this is where I'm going to stop today. Next lesson, we're going to look at doing electron configurations for ions, polyatomic ions particularly, but also transition metal ions. Sorry, not polyatomic ions at all, transition metal ions, cations and anions. All right, I will see you guys then.